This is a video solution for practice exercise 3. The goal of this practice exercise is to create a basic parametric transformer family with an electrical connector. Following the family creation best practices, we want to begin by creating the framework of the family with reference planes. On the Create ribbon, in the Datum panel, click Reference Plane. And then we'll create a reference plane for the left, right, and front and back sides of the transformer. And then we will also create a reference plane for the top of the transformer. And then click Modify to end the command. And if you want, you can actually select this level and drag the level head to get it out of the way if you want a little more room there. And then you can also adjust these reference planes after you create them, and even the default ones as well if you want to. You have to unpin them first, and then if you want to adjust their length. Just a side note there. Okay, now that we have our reference planes created, we want to name them, and we can set the isReference. And what that will do is determine the priority when they are loaded into a project, the priority that Revit looks for them whenever they're being dimensioned. And then the name will show up in the tooltip when you're dimensioning as well. All right, the next thing that we will do is create dimensions and create equality constraints so that we can, once again, continuing on to develop the framework of this family. So on the Annotate ribbon in the Dimension panel, click Aligned Dimension, and then we'll dimension between the vertical reference planes and create an equality constraint, and then the horizontal ones. That way the left and right and front and back will always be equidistant from the center. And then we'll create an overall dimension for the length and the width, and also an overall for the height. Okay, the next step is to create parameters, and we can create a parameter for the length, width, height, primary voltage, primary number of poles, and load classification. We can do that in the Family Types dialog. So either on the Modify ribbon or the Create ribbon, you can find the Properties panel where the Family Types tool is. So we'll click Family Types and then add those parameters. And after you add the parameters, you can select one and then use the Move Parameter Down and Move Parameter Up if you want to adjust the location. So I like to keep them in a nice order that makes sense to me. So in this case, length, width, height. Next, for our primary voltage, it is not a common length parameter, and so we will expand the discipline drop down and select electrical. And then the type of parameter will be electrical potential. And then we will group these parameters under electrical. And this will be a type parameter. Click OK. And our next parameter is primary number of poles. And once again, we'll need to change the discipline to electrical and then select number of poles. If I can find it, down at the bottom, and we will select electrical again to group it under that grouping. And lastly, we'll create a parameter for load classification. Make sure I spelled that right. And then we'll select electrical, and for whatever reason, those last two are not in alphabetical order. and we'll group it under electrical again, and click OK. And once again, you can select it and adjust the order that they appear in the list, which will this also determines how they'll appear in the project. And in this case, in the family types dialog, you'll see instance and type parameters, whereas in the project, you'll just see instance in the properties palette and just type in the type selector, but the order that they appear in will determine the order that they are in the list. Let's go ahead and specify these parameters. 480 volt, 3-phase, and for our load classification, we'll click the More button, and we'll select the transformer load classification, and then we'll click OK. Next, we need to label the dimensions with the appropriate parameters. And so I'll select the overall length here, and we can expand the label drop down on the contextual ribbon and select length. You'll notice that I didn't add any values to those dimension parameters, and when you label a dimension, it will take on whatever dimension that was set to. Whereas if you did specify them, then you could update those dimensions. So just be aware of that. Okay, now that we have those dimensions labeled, we can create geometry. So on the Create ribbon in the Forms panel, we'll use the Solid Extrusion tool with the Rectangle Draw option, and we'll create a rectangle, and we'll lock the sketch lines to the reference planes, and then click Finish Edit Mode. And then in the front elevation view, we will constrain the top to the top, and then the bottom to the reference level. And at this point, we can open up a 3D view, and we can see our box here. And for sake of example, I'm going to go ahead and just adjust the length, width, and height parameters. And we're kind of jumping ahead here, flexing it a bit, making sure it's constrained, but really just want to do that for just so that it looks a little more like it should at the end besides a big box. The next thing we want to do is add an electrical connector, and we can access those tools on the Create ribbon in the Connectors panel. We'll select Electrical Connector, and then we'll place it on the side. And if you can't get a side to highlight, you can press Tab and wait till that side highlights, and then click to select it. I will select the electrical connector, and we want to adjust the system type. We'll set it to Power Unbalanced, and then we can associate the parameters that we created to some of the electrical connector parameters. For example, number of poles, we'll click Associate Family Parameter and select Primary Number of Poles. For the load classification, we'll associate it to the load classification parameter. And for our voltage, we'll associate it to the primary voltage. And then you could adjust additional parameters and enter a connector description if you wanted to. For this case, in this example, this actually ends the practice exercise, and we just need to flex it and make sure that everything is constrained properly. And so we can enter in, you can enter in whatever values you want just to make sure that it updates appropriately. And it looks like everything's working like we want it to. And so we'll go ahead and enter in the values that we want. And we'll put this at 3 feet. And we'll make it a little taller. And as long as everything's adjusting, the length, width, height, as long as those are adjusting properly, then you know that you got your constraints correct. If not, then you want to go back and check those constraints. And this concludes practice exercise 3.